Hello everyone. So now that we have learned all there is to know about these lines, the different special types of lines of triangles, let's try to solve some problems using the various different properties. So starting with problem 7.26, find the area of ABCD given that AB equals BC equals 6, CD equals 3 times square root of 2, angle ABC equals 90 degrees, and that there is a circle passing through all four vertices of ABCD. So when we start this diagram, we should just start with the circle because it's easy to connect all your points after. So we got this nice circle here. I want to rename this to maybe like O, which will be the center. And then we got 4 points. We already have point B over here. Then we need point A, where it makes a 90-degree angle. So with C, so point A can be like there. And then C will be over here. And then some point D. Now it says quadrilateral or ABCD, which is just some sort of four-sided figure. So it doesn't really specify if it's a square or a rectangle, so we just kind of have to do some guesswork with that. So I'm just going to say it's over here, and then we'll connect A and D. So now that we got our diagram, we can start actually doing some. Let's make it a little bigger, and that should be good. Alright, now let's start figuring some stuff out. So the lengths of A, B, and BC are the same. So I can mark that in my diagram. Specifically, it's 6. And the length of CD is 3 square root of 2. And the angle at ABC is 90 degrees. And that's all it's telling us. So what can we do from here? Well, we don't know much about four-sided figures. We know a lot about triangles because this whole entire chapter was basically about triangles. So let's see if we could figure out something where we can make some triangles. So I'm going to actually label this angle here, and let's get it as close to 90 degrees as possible to make our diagram a little more accurate. And I don't need to actually see that it's 90 degrees. It's fine. We'll just know that that one's a 90-degree angle. And let's make some triangles. Now, we know a lot of stuff about isosceles triangles. And since these two sides are the same, I think that if I make a triangle from A to C, we'll get a nice isosceles triangle. Specifically, that's also a right triangle. That means it has to be a 45-90 triangle. So this is 45 degrees, which means that the length of AC is equal to 6 times the square root of 2. Because it's a 45-90 triangle. Alright, that gets us somewhere. And we should also notice, and this has to be true, that AC passes through O. And the reason that that is true is because since O is at the center, and we know that if AB and BC are the same distance away from, well, they're the same distance, that means A and C are the same distance from the center. So the line drawn through them is going to cross through the center. And now we have what is, well, we have two triangles. We have ABC and CDA. And they're both circumscribed on this circle. So I also know that the circumradius of this is half the hypotenuse, which is 3 square root of 2. 3 square root of 2. Just take the hypotenuse AC and divide by 2. 6 divided by 2 is 3. Well, that's interesting because I see that CD is also 3 times the square root of 2. Which means that if I can connect O to D to make another triangle, then those two sides are the same. Well, what do I know? Can I figure out what OD is? Well, sure. OD is the radius of the circle. And we just said that the circumradius is 3 square root of 2. Which means that this is an isosceles triangle. Which means that all the angles are 60 degrees. So we have 60 degrees here. And same thing over here. So we have a nice equilateral triangle. But now I should also note that AOD is isosceles. They both have the same length here, 3 root 2, because OD and OA are also the circumradius of the circumcircle, which means that this triangle is isosceles, and that this angle is the same as this one. Can I figure out what those angles are? Well, if this angle here is 60 degrees, then this angle right here is 180 minus 60, which is 120. Now, if that's 120 degrees, and these two angles have to be the same, well, the only possible way that's true, they have to add up to 180. So 180 minus 120 is 60. That means the remaining two angles have to be 30 degrees each. But I know that this is 60 degrees, which means that this whole angle is a right angle. 30 plus 60 is 90. I also know that this is 60 degrees, which means we have a 30, 60, 90 triangle. I know. Let me clear up a little bit so we can more easily see. I've shown that these two angles add up to 90, so I'm going to get rid of some of this stuff here. Let's get rid of that, get rid of that, get rid of that, get rid of this. Okay. So, again, we have shown that this is a 90-degree angle, and that this one's 30 degrees here. This is 60. We have a 30, 60, 90 triangle. Now the hypotenuse is 6 square root of 2. That means the side opposite is 3 square root of 2, which we already have, which means that the side AD is going to be 3 times, let me just write it out, AD is equal to 3 square root of 2. And since it's the side opposite to the 60-degree angle here, I have to multiply it by the square root of 3, which leaves us with 3 times the square root of 6 as the measure of AD. Alright, now do I have everything I need to know to solve the problem? Well, the problem was asking us to find the area of the quadrilateral ABCD. So, in order to find the area of this quadrilateral, I have split it up into triangles, and if I find the area of the portions of the triangles, then we can find the total area. So, let's take the half of the quadrilateral ABCD and find the area of triangle ABC. Well, 1/2 base times height is your area. Now, in a right triangle, the base and the height are the 2 legs, which are just 6 and 6. Well, half of 6 is 3. 3 times 6 is 18. Now, I have to find the area of the other half. So I'm going to find the area of ACD. Again, that's 1/2 base times height. It's a right triangle, so your base is going to be 3 root 6. And your height is 3 root 2. And multiplying that out, we have 1/2. 3 times 3 is 9. And then the square root of 6 times the square root of 2 is the square root of 12. And the square root of 12 can be rewritten as the square root of 4 times the square root of 3. Which means it can be rewritten as 1/2 9 times 2 times the square root of 3. But 1/2 times 2 cancels out, and we're just left with 9 times the square root of 3. So, now that we have found the area of both triangles, we found the area of A, B, C in that first part. And then we also found the area of A, C, D. And that entire area makes up the quadrilateral ABCD. So all I have to do now is take the 2 areas, add them together. So A, B, C, D's area is just 18 plus 9 times the square root of 3. And that is the answer to our problem. So, always remember, 90% of geometry problems are just triangle problems. So if you don't have a triangle, throw one in there. And chances are, from there, you can figure out your answer fairly easily.